In this video, we're going to learn about volume. So here's a simple example. It says find the volume of the pyramid below. Last video or last set of videos, we talked about what a pyramid is, what a solid is. I said the word volume once in there, but we never really went over what a volume is or how to find it. So what is volume? Well, volume is a three-dimensional measure of the space in a solid. And it actually counts the number of 1 by 1 by 1 unit cubes. An example that you might have seen in junior high would be something like this. If you had, let's do this. So if I had this rectangular prism, and said that it was 3 inches by 2 inches by 4 inches, you may come already knowing that I can find this volume by doing 3 times 2 times 4. 3 times 2 is 6, 6 times 4 is 24. But what does that mean? 24 what's? So here's what's going on. If I have 3 inches times 2 inches times 4 inches, the 3 and 2 and 4 do multiply up to 24. The inches times inches times inches is inches to the third power, inches cubed. And what that means over here is the following. So let me actually split this up. If this is 4 wide, let me split this up so I have the 4 wide. I'm going to even go back in here. So, and it's 2 deep. Okay, so 2 deep. And then it's 3 tall. So I do 1, 2, so now it's 3 tall. What I have is if I took one of these cubes, like this cube right here in the corner, and took it out, so I have a 1 by 1 by 1 cube, there are exactly 24 of these cubes in this solid. If you've played Minecraft, it's like building a really, really ugly wall out of dirt blocks in Minecraft. I have 24 dirt blocks, gonna make a wall that's 2 deep, 4 wide, 3 tall to keep those creepers out. Okay, so that's what's happening. It actually measures cubes that fit into it. If you played with blocks as a kid, that might be another connection you have there. So we're going to consider 2 types of solids. There are many others, but most of the others, you just have a formula, you put the numbers in the right spot, and you get an answer. It's not that hard to get these. The first one is going to be the volume formula for prisms. And I'll give you the more confusing format right now. So in a prism, I could have V equals B times H, a capital B, lowercase h, and this capital B is the area of the base. Now, we, for our purposes right now, are going to use a specific type of prism. We're only going to do rectangular prisms. Rectangular prisms. And the rectangular prism has a rectangle at the base. So the base area right here is just going to be length times width because that's the area of a rectangle. And I still have this times height. So for a rectangular prism, I just have length times width times height. But in general, I could have different shapes at the bottom, or I could even use this for something like a cylinder, same base formula. So if you want to get a broader understanding, you can use this formula. If you just want to get some answers and see how it works, this will get you there. the volume formula for pyramids. Now, a little more to pyramids. So, of course, pyramids, we know, this is going to be sort of a rectangular pyramid, but they come up to a point. And a common thought for my students is, I see triangles, so is this volume equal to 1/2 and then something? Put a little question mark there. And the answer is no, it's not equal to 1/2 something. It's going to be equal to 1/3 base area times height. A quick reason for why it's 1/3. Again, you don't need to get this yellow part. I'll put up the more direct formula for rectangular pyramids in about 50 seconds maybe. But the reason it's 1/3 instead of 1/2. If I took a rectangular prism, okay, we know this is base area times height. And I took my saw and I cut off this and this to make a triangle, so I got rid of this waste. Okay, that's all gone. I don't have a pyramid now. I actually have a triangular prism. Okay, notice it's like a tent shape. So this is already 1/2. I actually need to go back in and cut off even more. I need to cut off this area here and that area back there to get here. Now I'm not going to go specifically why that is 1/6 of the total volume, or 1/3 of the remaining volume. It is, but you could show with some calculus. But long story short, it's definitely less than half of the original volume because I've taken off more than 1/2. Okay, that's a lot of sort of speech for how we get 1/3. The one you're going to use for our work today is going to be the volume for rectangular or square pyramids. And that simplifies down to 1/3, but the base is a rectangle, so the base is length times width, so 1/3 length times width times height. And so this is the formula that we're going to use for our problems, even though in more general cases I have 1/3 base area times height, which can also be used for cones. Okay, so back to our original problem. I see I have a pyramid, I see I have a square pyramid, and I just realized, oh, well, my formula says volume is 1/3 length times width times height. The length is 5, the width is 5, the height is 9. So I get my volume is 1/3, 5 times 5 times 9. And I'll go to the calculator. I could do it in my head, but so 1/3, so 1/3 times 5 times 5 times 9 gives me 75. And this is a volume. Recall that volumes are three-dimensional measurements. So I have meters, but it's going to be meters to the third, or cubic meters, or meters cubed. Okay, another example. Find the volume of the prism below. So this is a prism. I don't need the 1/3, so I can just do volume equals length times width times height. Length is 4, width is 3, height is 5. So I get 4 times 3 times 5. 4 times 3 is 12. 12 times 5 is 60. And it is a volume, which means it is cubic, so I'll have meters cubed. One more example. Find the volume of the pyramid below. So this is a rectangular pyramid. I see I have a 4x6 rectangle at the bottom. It's a pyramid, comes to a point at the top, so I know that I'll have 1/3 length times width times height. The length is 6, width is 4, height is 5, so I'll have 1/3 times 6 times 4 times 5. And I believe it's the same volume, but I'll double check. So 1/3 times 6 times 4 times 5 gives me 40. Okay, I messed up. I thought this was a 9. Okay, so this would give me 40 inches, and again, it's a volume, so inches cubed. Okay, I hope that made sense. Generally, much easier to compute than surface areas, especially for prisms and pyramids. Conceptually, actually, a more difficult concept to grasp what you're finding, but the work you're going to generally do in a high school classroom with finding the volumes is usually pretty easy. There will be a link in the description down below to some more examples of me finding volumes so you can make sure you have the correct understanding. And there's also a link to a worksheet so you can get some practice on these on your own.